Okay, write this down, please. Velocity time graphs. Got it? Okay. Yeah, so we're going to be looking at graphs now for a little bit. Okay, so just some things to take care of with signs. So, when we're talking about moving horizontally, we use positive to mean to the right, and of course, negative to mean to the left. And when we're talking about vertically, we use positive to go up, and we use negative to go down. You can change these if you want. So if you really wanted to say to the left positive and down positive, you can. It's not wrong. It's just I'll stick to using this. So I'll do positive means this way, positive means this way, negative this way, and negative this way. Okay. So just write this down. You don't have to write all of that, but just write something down to remember this. Okay. So positive, positive, negative, negative, and also it's okay if you swap. It's fine, but just be careful. So I'll stick to doing it like this. But in fact, if you did something like this, which some people do, sometimes it makes the question easier. This is also okay. But I will usually not do this. Yes? Okay, so write something down. You don't need to copy Sophie. You have your own ideas. Okay. Continue? Okay. Yes? Okay. So if you had one number, it could be a vector. So for example, if s equals 1 meter, that means 1 meter to the right. If s equals minus 1 meter, what would that mean? 1 meter to the left. So a single number could also be a vector. Positive means direction is to the right, negative means direction is to the left. So positive and negative can show the direction. I think it might be good if you write this down. Okay, you wrote something? Yes? Is Monday a busy day or a good day for you?
Good day.
Why good?
Yeah.
At 3 o'clock?
Yes.
Nice. Go home to study maths and physics, yeah?
No.
And maybe some games.
Yes.
Yeah. Some.
But go home at 5 o'clock on Friday.
5 o'clock on Friday?
Yes.
That's okay.
No.
That's okay. What's your last class on Friday?
Everything.
Ooh, tough.
Ooh.
Yeah, ooh, yeah, okay.
That's horrible.
Oh, okay, so
So sorry.
yeah, yeah. You have maths class tomorrow with the other maths teacher.
Yes.
Mhm.
Female?
I'll let you figure it out. Okay. Male, by the way.
Yeah.
Yes.
Is
Uh,
tall? Wear glasses? Long hair?
Yes. Long hair. No. Tall, wear glasses, but not long hair. Well, what do you mean by long hair?
My rock star.
No, he's not a rock star. Sorry to disappoint you. Okay. Right, so acceleration. So this is a definition. Acceleration A is a vector. And acceleration is the rate of change of velocity. And so as a formula, it's like this. Acceleration is the change in the velocity divided by the time for that change. So that's the change in velocity, and then the t part is the time. Sorry. So our class went from 100% male all the way down to now you're only 25% male. Okay, you got this, guys? Not yet?
Yes.
Okay, so just to be clear, for example, like here, if he starts at 0 meters per second and then he starts to run, and now he's moving, let's say, at, I don't know, 10 meters per second, and it took him 1 second to do this. We say his acceleration. How much has his velocity changed? Has he gone faster or slower? He's gotten faster by 10. Yeah? And how long did this take? 1 second. So we say its acceleration is 10. But yeah, what's the unit? So that's it. Let's have a look at the units here. So A equals this divided by this. Okay. So what's the units for velocity and then the units for time? So if you remember, velocity's dimensions is length per time. And then time is just time. So this is length per time minus 2. So what units? So what units do we measure length in? Meters. And time? Seconds. Yeah. So the units are meters per second squared. Might be good if you write this down. So this is the dimension, and then these are the units. Okay. Meters per second squared. That's okay, is it? Yeah. Okay, can I continue? No. Continue? Yeah? Okay. Right. So just some letters here that would be useful to know. So the letter U is we use to represent the velocity at the beginning. And it's also called the initial velocity. V is the velocity at the end. This is called the final velocity. Of course, you know what the A is. What's A? It's the acceleration. How much the velocity has changed. T is the time for going from U to V. And S is the displacement, also called the position. That is where it is at the end compared to where it was at the start. We need to be careful about that. We'll talk more about that in a moment. So sorry, go back here a sec. So please write these names down. Yeah, good question. How much time has elapsed? That another word is how much time has passed, how much time has taken place, how long it was. Like here, look. So for example, if I start here for start, you go 1, 2, 3, 4, stop. We call this time elapsed. Time spent, yeah. Yeah. Sure, look, he had the maths teacher last week. You can ask him about the maths teacher. Tall?
Yeah.
Yeah. Glasses?
Mr. Roland.
Yeah. Long hair?
No.
No, yeah. The physics teacher before me had very long hair.
How long?
Like Sophie. Yeah.
A man?
Yeah. Yeah. And sometimes.
He runs.
Yeah, because he played the guitar. You know?
Lauren's like his husband, her husband had long hair before.
Not long like to here, maybe like to here.
And Lauren, she hates it.
Yeah, yeah, I understand. Okay, you got this written down? Yeah. Alright, so just be careful about the last one, the displacement, okay? So for example, look please. So let's say, I don't know, this is like 1 meter, for example. I know it's not, let's say this is 1 meter. So this starts here, and if it moves from here to here, the S is 1 meter. Yes? Now if it moves from here to here to back here, in the middle, what's the S? 0.5 meters, yeah. If it moves from here, back to the start, S is 0. Yeah. So the S is like how far away it is from the start. That's okay? Yep. careful here. If this is 0, this is plus 1 meter, this is 0, so what would be down on the ground? Minus 1 meter. Are we okay with that? Yeah, that's good. Alright. Can I continue, Grace? Yep, alright. Okay. So, another example to help you see Usain Bolt. What's the U? 0. He starts at rest, like everybody else. He starts at rest. The T, do you know his T?
Yeah, 9 seconds.
Oh, not that fast.
9.99.
Not that slow.
9.
It's like 9.6 or something, isn't it? Yeah. The S you should know.
100 meters.
100 meters. Isn't it? 100 meters? And the V, I think I know the V. Does anyone know the V? I think he finishes at about, oh my goodness, like about maybe 13 or 14 meters per second. But so you think about it, right? Picture 13 meters or 14 meters and traveling in 1 second. Pretty fast, right? Pretty fast. So that's the example of U, V, A, T, and S. Okay, and you can calculate the A as well. Okay. So please remember that velocity can be positive or negative. So this is positive and then backwards is negative because it is a vector. But speed is only positive. Speed is only positive. Also, displacement can be positive or negative. Remember, plus 1 meter or minus 1 meter. Because it is a position. I should also say because it's a vector as well. But distance can only be positive. So my example here, if this goes up and then back down, the S is 0. But the distance is not 0 because it traveled 1 meter and then another meter. Do not confuse speed and velocity or distance and displacement. Sometimes they are the same, but they're not always the same. You have been warned. So because this is in red and bold, it's important enough for you to write down. Now you don't need to write everything down, but write enough down that you can remember the important message. That velocity can be positive or negative, but speed is positive. Displacement can be positive or negative, but distance is positive. Right, something, yeah? What have we got? Velocity can be positive or negative, speed only positive, displacement can be positive or negative, distance only positive. Hungry already? It's not even 12 o'clock. Did you have breakfast?
Not finished.
I see you're looking at your lunch thinking, oh, soon I will have it. No breakfast? 1 sausage? 2 sausages? Sandwich. And you're still hungry? Big sandwich? Oh, only 1 sandwich, yeah? What was on your sandwich? Oh, let me guess. Ham? Yes, of course, yes. And butter? No butter? And what? Cheese? What? Ketchup. Nice. For breakfast. Ham and ketchup breakfast sandwich.
No, we have cheese.
And you had cheese with yours?
Oh.
You had cheese?
No, cheese. No butter.
Yeah. Ham, cheese and ketchup. Sounds nice. Alright. You got this? Yeah. Because they're so delicious. Yeah. All right, do you have this?
Yes.
Yeah. All right. Okay, so next. Right, so what we have here is called a velocity time graph. So actually, maybe before I give you this difficult one, I can show you one with like Usain Bolt again. So the way we draw these graphs is we put time on the x-axis and then velocity on the y-axis. So Usain Bolt, he starts at what velocity?
0.
0. And then maybe after, I don't know, 1 second he starts to run fast. And when do you think he's at his fastest?
Maybe 5 seconds.
Yeah, maybe even less than that. So he keeps running until he's at his fastest, and then he can't run any faster. So then he continues at this top speed, whatever that is. I'd say it's about 14 meters per second. He continues at this top speed until the very end, which is 10 seconds. And then what happens after 10 seconds? Then he's
Stops.
slowly relaxes, slowly starts to slow down. Or maybe if he's very tired, he falls on the ground, plop, and stops very quickly. But anyways, this is the idea that you put the velocity on the y and the time on the x. Okay, so here's a little bit more difficult example, but it shows you all the different possibilities. So this person or this car or this train or whatever it is, let's see what's happening. So at the beginning, what do you say about it at the beginning?
Accelerates.
No, at the very beginning.
Oh,
It starts at rest. Yeah. Now, because the line is not so steep, it means it slowly accelerates. But then what happens if I don't have anything to point at. I need my meter stick. Alright, doesn't matter. What happens there?
Moves faster.
Yes, when the line breaks. Oh, well, I'll wait for you to draw it. Or maybe you can listen first before you draw it. Yeah. Yes? Yeah. So, at the beginning, when it's like this, it means it's starting to move slowly. But then what do you think would, if it's a car, what do you think happens when it went from like this to steeper?
Faster.
Yeah, but describe it in terms of a car, okay? So, at the beginning, the car is not moving. So what do you think the driver did at the start?
Step on the brakes.
At the brakes?
I mean, because at the start it's still a 0.
Okay, at the start, the car is off, the engine is off. Yeah? So he turns it on, and then
he steps
he steps on
on the accelerator.
the accelerator, hard or soft?
Soft.
Gently.
Yeah.
And the car starts to move slowly. Then what happens there?
She steps on it.
He steps on it harder. So what happens to the car? It accelerates more. Yeah? Now that piece at the top is flat. What's happening there?
Constant speed.
The car is moving at a constant speed. So what would cause a car to move at a constant speed?
When it's at its top speed. Right? Or if he doesn't move his leg.
No,
He doesn't.
keep it more boring than that.
Uh,
What is keeping the car at this constant speed?
because there's a speed limit.
Speed limit. Maybe the speed limit is reached. Yeah? Now, the car suddenly slows down. What would cause the car to suddenly slow down?
Traffic light.
Maybe not that sudden.
That's a crash in front.
Yeah, a person jumped out in front. Yeah? So he puts his foot on the brake, and you see here, it stopped. Now, notice now it goes under the graph. So that means the velocity is negative. So if the velocity is negative, what's happening to the car?
It's going in reverse.
It's gone backwards. And then it's constant speed. So what does that mean? Constant reverse. So when a car is reversing, it can't go as fast. So this one, I think, is like the top speed of the car in reverse. Okay. So the velocity time graph is like a story of the motion. Okay, so like here, yeah, he puts his foot on the gas, then he puts his foot down harder and get really fast. This is the top speed. Then somebody jumps in front of the car, he puts his foot on the brake, and here he's not moving. And then he wants to go backwards to get away from the person, so he reverses, and then he's moving at constant speed backwards. Yeah. And then if he stops, what would be the next part if he stops? What way would the graph go if he wants to stop? Yeah, it'll go up and then flat on the x-axis. Yeah, is that okay as well? Yeah, okay. So everything you need to know about the journey is on this velocity time graph. Okay. Next. Oh, sorry, you want to draw it? Let's see, what else now can we say about the graph? No, not much to say, except for the units, but you know the units. What's the units on the time? Should be seconds, yeah, and then on the y, the velocity, yeah, meters per second, yeah. Okay. Have you drawn that? Everybody's waiting for you.
You said listen and don't.
That's true. And these three girls here, they never listen to me. They never do what they say.
20 minutes break.
No. How about no break, and then we'll finish a little bit early, and then you can get your second ham, cheese, ketchup sandwich.
Well, what is a little bit early? I would have it a little bit early. It's not early at all.
I promise.
No.
Promise.
No, don't believe me.
22.
What if?
You can walk out. Okay? At 22. Promise. Trust me.
If it's after 8, not over. Okay, excellent. 8
Okay, yes, deal. Alright, you got that drawn? Yep. Okay. So let's have a look at a question. So I would like you to try and draw this first for me, and then I'll do it. So you have a car, starts from rest, it slowly accelerates to 20 meters per second over 10 seconds. It then maintains its speed for 5 seconds before suddenly decelerating to rest over a time of 4 seconds. Draw the velocity time graph. Oh, just before you go ahead, accelerating, and then the opposite is decelerating. So accelerating means go faster, and then you see there decelerating, that means go slower. Yes? You know what I'm saying? Yeah. Did you know this already? Decelerating
Yes.
means go slower. Okay. I would like you to try and draw this. And yes, write down the question too is good. So try this question, please. brackets, Augie? Yeah, just put the units and the units. Yeah. No problem, yeah? You have breakfast? That's terrible. You never have breakfast? Grace always has breakfast.
Of course.
You need to.
Yes, of course. I'm hungry.
Yes. So much studying makes you hungry.
Yeah.
Yeah.
Very hard.
Oh my goodness, so hard. Let's see. And you need the units too. Yeah. Good. I prefer when the units are with the slash, not the brackets. You know what I mean? Like V/MS. Yeah. Okay, you're drawing it, and have you drawn it?
No.
Not yet, but you're about to. Okay. Yeah, what? What have you done?
No, nothing.
No copying. You can do this. Don't show her. Don't show her. Yeah, you can do it. You can practice your English. I know you do. All right. Let's have a look. Okay. Amanda, can you read the question back to me, please?
A car starts from rest.
Okay, so start from rest.
They slowly accelerate to 20 meters per second over 10 seconds.
Okay, so over 10 seconds it accelerates to 20. So it goes like this. Okay, next.
It
Maintains.
maintains its speed for 5 seconds.
So it goes like this next.
And suddenly decelerating to rest.
In 4 seconds.
Well, yeah.
Okay, so this is the graph you should have. Okay? Yeah. Beautiful like mine. Alright. Okay, so you might remember this from middle school, do you? This triangle. And this triangle can tell you the distance, the speed, or the time. Huh? That's what it's called. Dad's silly triangle. Look. DST. Dad's silly triangle. Distance, speed, time. Distance, speed, time. That's what we call it here. Anyways, if you want the distance, you can see that it's speed multiplied by time. And if you want the time, it's the distance divided by speed. And if you want the speed, it's the distance divided by time. So the triangle is this. Distance, speed, time. So if you want the distance, what is it? Speed multiply time. If you want the speed, it's distance divided by time. And if you want the time, it's distance divided by speed. One important note. This is only true if the acceleration is 0. This means if the speed is constant, if the speed does not change. Okay. Only works when the velocity is not changing. I should actually say the velocity, yeah. So you just draw this triangle, and please note for this triangle there must be 0 acceleration. Okay. You just need to draw one triangle. You got it? You used this triangle in middle school, yeah? Or not? First time seeing it?
Yeah.
Really? Wow, excited. Grace, Sophie, Amanda, did you use this triangle in middle school?
No.
Really?
No. We just first time study here.
This triangle, you've never seen it before, Ireland. Wow. Sophie, you've seen it before? In middle school or high school? Yeah, middle school, I think. Okay, continue? Yes? Alright. So what if the velocity changes from U to V? So it doesn't work when the velocity changes. Okay. What the heck? Okay. So this is just a simple question to practice the triangle. And in fact, I think you can do it. You don't need me to show you how to do it. So the distance to school is 2 kilometers, and it takes him 30 minutes to walk this journey. What is his walking speed? You may assume it's a constant speed. That is, the speed at the start and in the middle and at the end is all the same. So I want you to use the triangle to tell me his speed. Maybe. I haven't worked out yet. What was the answer in kilometers per hour? You got an answer? Yeah. You got an answer? Huh? How much? No, don't be shy. How much? No? Okay. I think that's what you got as well, wasn't it? 1.11? Yeah. Congratulations. Okay, so since everybody did it now, let's have a look at it. So what do we want? We want the speed. So that's distance divided by time. So the speed is the distance divided by the time, which is, what did I say, 2 kilometers divided by 30 minutes, which is 2,000 meters divided by 1,800 seconds. So that is 1.11 meters per second.
Can you answer in kilometers per minute?
Yeah, that's fine. That's fine because I didn't say in the question. But we usually stick to this. Yeah. Okay, can I go continue? Yep. Right. So, why does a velocity time, that should say what? What does a velocity time graph tell us? So you might think that it only tells us the velocity, but in fact, it can tell us much more. Much more. So
The
let's see.
area is the distance, right?
That's right, yeah. Let's have a look at all of it now. Okay, so let's say this is time and this is velocity, and it doesn't matter. Let's say this is like 10 meters per second and this is 2 seconds. So if the boy walks at 10 meters per second, for example, for 2 seconds, after 2 seconds, how far has he travelled? So 10 meters per second for 2 seconds.
30 meters.
20. Yeah? Or no? You seem confused. Yes, you're confused. So the boy walks at 10 meters per second. Yes? And he does this for 2 seconds. So my question is, how far has he walked? How far? Say again, I can't hear you. Correct. Thank you for listening. Okay. 20. Which is 2 multiplied 10. So I'll just call this T and I'll just call this V. So here's his graph. He's walking at 10 meters per second for T seconds. Now, if I was to calculate the area here, what unit would that be? Let's have a look. The unit will be, area is the unit for dimension for V multiply dimension for T. What's the V? What's the dimension for V? It is, meters per second, length per time. And what's the T? Time. So they cancel. So what's the unit for the area? No, just meters, because it's just length. Okay. So this unit here is in meters. So what represents meters?
The area.
But what do you measure meters in? The distance. So in fact, you can see here, the result is that the area equals the distance the boy has travelled, or whatever has travelled. So this is the first result. Area is equal to distance. So look, wait, just try not to write it down. Try to listen for 10 seconds. So if this is 10 and this is 2, what's 10 multiplied 2? 20, which is what we said earlier. Okay, so the area is the distance. Okay, now continue. Yes? You're the first one finished, Grace? I guess so. Yeah. You have so much power from your breakfast. None of them have breakfast. This is why they're so slow. Did you have breakfast on the back?
Yeah, I did.
What did you have?
2 toast bread.
That's nothing. What happened? Problem? No problem. Okay, continue.
No.
I didn't tell you what happened to my new shoes last Friday. Remember I got new shoes? 50. 15. I was walking through town and I was thinking, what's that smell? I can smell something. Oh well. Then I was sitting on the bus and I was thinking, I can still smell that. What's that smell? So then I get home and then I cross my legs at the table. Now I can really smell it. And I looked down. I stood in dog poo. Terrible. Oh, it was terrible. Oh, it was terrible. Is that the fire alarm?
Yeah.
We probably should go, huh?
No.
Yeah, no, I don't want to either.
Let's go.
Don't, hang on. It's still cold. That's fine. Right, what I'll do is I'll pause this. It'll probably only be 5 minutes.
Is it like a fire drill?
No, I think it's probably a false alarm. So I'll just pause this. Well, follow me, I'll save you, and then we'll come back in a minute.
So are we still leaving at 12:30?
Yes, that is the plan. We'll try and stick to it, okay? Right, so next part now. I can scroll down? Yeah. Right, so have a look at this now. Suppose, here's our time velocity graph again, and we start here, and then we accelerate to here. And this is velocity, and this is time, and this is u, and v, and this is t. Yeah? Okay. What is the point here, the coordinate? It will be 0, u, right? Yeah. And here, t and v. So let's calculate the slope of this line, the gradient. So from maths, you know it'll be y2 minus y1 over u2 minus, y2 minus y1 over x2 minus x1. So this here, v minus u, this is the change. How much the velocity changed, isn't it? That's this thing. And this t is how much time was spent. The spent time, which we call this. What do we say this equals? Acceleration, yeah, the gradient, yeah. So we have this result now, that the slope, or the gradient, is equal to the acceleration. Yeah? So this is good, because it means on our graph we have time, velocity, acceleration and distance. Yeah? Yeah? Continue? Or continue? Yeah? So to summarize, u is the height at the beginning, v is the height at the end, a is the slope, t is the base, and then s is the area. You can find, so sorry, just to maybe to draw it here, like for example. So if we have something like this, this height is the u, this height is the v, this base, what's this base here? The t, this area, the s, and this slope is the a. So, yeah, everything's on the graph. Yeah.
So, if there were a graphic, I mean like the earlier example where it goes negative,
Yeah.
if they were to ask the displacement has to be the positive minus the negative, right?
We don't usually deal with messy problems like that, but we would. But
if it's distance, it's just plus.
it's just, both positive. You would have to add the positive and negative areas together. Yeah. Okay. Did you make notes on this? Yep. Continue. Yep. Right. So what we have here, we have a table, and I'd like to plot this table and get the distance, the acceleration, and the deceleration. So what I want you to do first is just copy this table, please. Copy this table. Oops. got this? No. I just need the table first. You got the table? Yeah?
No.
No?
Not yet.
Am I still recording? I hope so. Yeah. Yes. I can do it now?
No, not yet.
Oh my goodness. Well, I tell you what. First thing I want you to do, if you have it, is to draw this. Let me see what you draw. Yes, draw. Nice. Yeah?
Plot this data in a suitable manner. It basically means draw the graph, right?
Okay. Nearly, but it goes down to 0, 0. Okay, let's have a look at this. Right. Would you like an ugly or a nice graph?
Nice graph.
Ah, great, okay. Let me draw you a nice one then. Okay. Can you tell me the times? What are the times? 0, is it?
Yeah.
Next?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Huh? 10. And the velocities?
0,
0?
5, 10, 15, 20, 15, 10, 1, 5.
Alright, let me draw you a beautiful graph. Uh-huh. Okay. Yep, like this. Title, my beautiful graph. Time in seconds and velocity in meters per second. Oh yeah. So nice, my graph, isn't it? Right, so the first let me make it a little bit bigger actually. Ooh, too big. Oh no, it's actually not. Okay, So the first question was, what was the distance? Yeah? Is that the first one? Yeah. So you should break this up into how many shapes? I'd say 3 shapes. Look. So this first shape here, what's this one? Triangle. So we need the area of this triangle. Oh no, maybe more than 3. Triangle. Oh no, let's not get fancy now. Keep it simple. Triangle, and then here there's a rectangle, and then here there's a triangle, and then here there's a rectangle, and then there's a rectangle. So I might have to do a very, very, very ugly picture here. Okay, so ugly, I know. What happens? It goes up, across. What happens next? Up, across, down, across. Up, so quickly. Across, down, across. So if we want the area, I should make, let's see, this one, we'll call this one 1. And then here can be 2. And then here, this area can be 3. And then this area can be 4. So the distance, which is the area, it's a half. Okay, how big is this base, please? This is 4, is it? And the height? 20, is it? Okay, plus, and this one?
1.
And this one is still 20. Plus, and we'll do 3 next. This here, how big is the height here? 5. And here?
3. I mean 2.
Which?
2 seconds. It's from the 8 seconds.
It's from here.
Oh.
5 to 10.
Sorry.
So it's a 5. 5 times 5 times 5.
It's 5.
Thank you. 5 times 5. Yeah. And then the last one is here. Half of how big is this base here? It's 3, is it? It's quite big actually. 3. Yeah, 3 units. And the height is 15. 3 times 15. Alright, so let's add this up. That's 2 times 20 plus 20 plus 25 plus 1.5 times 15. So I got 107.5 meters. Yeah? Okay, the next part is the acceleration, which is here. So there's a quick way to calculate acceleration. So if you have a line on a graph, the slope is equal to this divided by this. This divided by this. That's the slope. So if I go back here, if I want the A, I'll call this A1. A1 would equal this height. How big is that? 20. And this base? 4. So it equals 5 meters per second squared.
That's the gradient.
Yeah. And now we want to get this one next, the deceleration next. Okay. So I'll call this one A2. How big is this? How big is this here? How big?
15.
It's 15?
Yeah.
And how big is this part? 3. Now we have to put a minus because it's going down. Is that right? Yeah?
What?
It's 15 height and 3 base. Yeah? So that's equal to minus 5 meters per second squared. But we have to be very careful about some English here. It said deceleration.
Yeah.
So the minus is already in the name. So we don't have to write the minus again. So we could say deceleration is equal to 5 meters per second squared because the minus is already in the D part of the name. Okay. So that was part A, B, and C. Continue. Okay, that's everything there. Alright, so these are your 3 questions for homework.
It's 3.75, right?
Promise, yeah, promise. Huh? What's 3.75?
Was it 3.75, the deceleration?
I thought it was 5.
But it's, we did 15 divided 4.
Somebody told me 3. Who told me 3?
Oh no, it's 3, it's correct. Yeah, I got it.
Hang on. This height here is 15.
No,
It's 3, yeah, okay. All is cool. Okay, these are what I want you to do for...
Friday homework.
No. It's only one homework, come on. When's physics? Tomorrow? Yes? I think so.
Yeah, tomorrow the first and second period.
Oh, like... Okay, no, not like today.
9 to
Okay.
11.
Right, so please do these 3 questions for tomorrow morning, and then at the start of the class I'll do them first. I'll put a copy of the questions up on Moodle as well. I think they're already there though. Okay, but if you want to take a picture on your phone, you can.